The first spark of creation, a cry into the unknown. In a moment of silence and awe, a tiny living thing breaks out of its fragile eggshell or comes out of its warm mother's womb into a world it has never seen before. It has no experience, no memory, no learned knowledge, but as soon as the air touches its lungs for the first time, it starts to do a series of complex actions with amazing accuracy. The baby sea turtle just hatched on a sandy beach instinctively knows its way to the sea even though it has never swum in it before. It moves purposefully towards the waves, avoiding obstacles, driven by a hidden force that guides it to its blue home. This scene happens again and again, every moment, in every corner of this planet. A small calf stands on its shaky four legs minutes after being born, looking for its mother's udder to drink milk. The bird chick opens its small beak wide as soon as it feels its parent's shadow over the nest, asking for its food. The butterfly larva knows how to spin an artistic silk cocoon, which will protect it during its mysterious transformation. All these behaviors are not from trial and error, and they are not lessons learned by the young from the old. They are preset programs, working perfectly from the very first moment, as if they are instruction manuals that come with every living thing. It's a moment that makes you stop and think deeply. Where does this inborn knowledge come from? Who put the roadmap in the head of the newborn turtle? Innate behavior programming, or what we often call instinct, is a set of complex behaviors and patterns that a living thing is born with and doesn't need any learning or past experiences. Let's take the bee as an example. The worker bee that leaves its hive for the first time knows its job exactly, without any guidance. It knows how to gather nectar and how to return to the hive, and how to do the famous waggle dance to tell its friends the location of the flowers with amazing accuracy. And similarly, the spider that weaves a complex web, its design differs from one type to another, but it stays the same within the same type. It didn't watch its mother weave the web, and it didn't go to school to learn engineering. The Venus flytrap plant has a complex inborn system to quickly close its leaves on an insect that touches its sensitive hairs. And also the movement of the sunflower that follows the path of the sun in the sky from east to west. An inborn behavior programmed into its internal biological clock. When we think about how precise and complex this innate behavior programming is, a question comes up strongly that cannot be ignored. Where did this code come from? If every computer program needs a smart programmer to write its code, then who is the programmer who wrote and put these extremely complex behavioral codes into living things? Just the fact that this programming exists shows us an amazing truth. Information comes before matter. The knowledge of how to build a nest, how to dance to find food sources, and how to migrate for thousands of miles was already there as coded information. Let's imagine for a moment that we found a fully working iPhone on a deserted island beach. Would any sane person think that this complex device, with its operating system and apps, came from the waves, wind, and sand over millions of years? A single living cell is more complex than any human technology, not to mention the behaviors of entire communities like ants and bees. For Arctic terns to travel from the North Pole to the South Pole, covering a distance of 40,000 kilometers back and forth, they don't just need an instinctive desire to fly, but a complete system. They need an internal compass sensitive to the Earth's magnetic field, a precise biological clock to tell the time of day, and the ability to navigate by the stars and the sun. The beaver doesn't build the dam by accident. It chooses the right spot in the river, fells trees in the right direction so they fall into the water, and then gathers branches and mud to build an engineered structure. A cat born in Tokyo and another born in New York have never met, and there's no connection between them, yet both perform the same movements when playing. An ant from the Amazon rainforest and an ant from the deserts of Africa, if they are of the same species, follow the same strict social rules in their colonies. Let's take bird songs. They might seem like just pretty random sounds to us, but they are actually a complex language. Each type of bird has its own special set of songs and sounds. Ants, for example, mostly talk through a chemical language. They release chemicals called pheromones to leave trails that show the way to food. Among all innate communication languages, the bee dance stands out as one of the most amazing things. When a worker bee finds a rich source of nectar, it goes back to the dark hive and starts doing a symbolic dance on the honeycomb. From the depths of the beehive, we now move to the vastness of the oceans, where we find another language miracle that is just as impressive: the songs of humpback whales. These songs last for many hours and can be heard for hundreds of kilometers underwater. And what's amazing is that every group of whales in a certain area, like the North Atlantic, shares the same song in a certain season. The link between genes and behavior is key to understanding innate programming. Genes found in the DNA strand are not just a blueprint for proteins and body parts, but they also carry a huge amount of behavioral information. Let's take nest-building behavior in birds as an example. The weaver bird, for instance, weaves a complex and artistic nest with its beak and feet. The nest's design, the shape of the knot it starts with, and the materials it chooses are all set in its genetic programming. This is exactly like an architect drawing a blueprint, which is information before the workers start building the building, which is matter. The blueprint is the origin, and the building is the result. If we put together all the threads of this amazing phenomenon, from the beginning of the first living thing to complex communication languages, and from the unity of behavior to its coding in genes, we will reach one logical conclusion. The Holy Quran clearly explains this truth in many verses. Allah Almighty says, "Our Lord is He who gave each thing its creation, then guided it." This design is not only seen in the behavior of one creature, but also in the harmony of the entire ecosystem. Innate programming ensures that every living thing plays its special part in this big cosmic system. And when we see these amazing signs in the smallest creatures, we can only say with a humble heart, "Our Lord, you did not create this in vain. Glory to you, so protect us from the punishment of the fire."